heads around what it costs to 3D print. And so we're just going to go over a couple things that'll help you understand that a little bit better. The cost, number one factor that drives the cost is the mix that you're going to use. You have mixes that are 600 psi, you have mixes that are 50,000 psi. Obviously, when you start adding synthetic fibers, different things like that, you're going to increase the cost of your mix. There's a motivator to have stronger mixes because with the right mix and the right formula, you're able to get away from rebar, which is heavy, costly, and you don't have to pour the wall solid with concrete afterwards. So we've done tremendous amounts of testing. In fact, most of the work that we have done hasn't been in building a printer, it has been in watching walls fall down every day with different types of mix so that we can get the math and the algorithm of how that mix is affected by wind, humidity, temperature, and a lot of other factors. So the mixes are all sent down and they're tested. They give us a 28-day report of the curing time, and then they'll take these, separate take the plastic off it, and they will do a break test, and they will come up with strength, and they'll tell you what PSI we are hitting. Anyway, so that's one factor. But let's just take a mix. Let's say a cinder block's 1800 psi. Let's just take a mix that's about 2,500 psi. Let's just pick that mix, okay? Bear in mind, there's tons of different mixes and there's 100 different additives. But we're just gonna pick, 2,400 psi. So you're printing, much more than what the strength of a cinder block. So there shouldn't be any building department issues. And when we're talking about printing, is it going to pass code? Is it going to pass code? Guys, you can build a house out of polystyrene, okay? Plastic, foam, and build your walls with that, put your rebar in it, pour it solid with concrete. So if you use the printer for nothing more than just printing your little polystyrene block wall, your forms, let's say, and then putting rebar in it and filling it solid with concrete, there's no code anywhere that we can't pass. Cinder block, the same thing, okay? We print, most of the time, 50% to 100% stronger than a cinder block. If you're curious about that a little bit, look at the video where we're shooting guns at cinder block versus our walls, okay? On our walls, the bullets bounce off the wall. On cinder block, it shatters. So, just simplify this. Don't make it too complex right now. Pretend we're just printing polystyrene block. Okay? No structural strength whatsoever. Your structural strength will come in with the rebar and pouring it solid. Okay? That's not what we do, but let's just simplify it. Let's take it back to just printing a dang foam wall. Okay? That'll help you a lot. So what you're getting with the concrete printer is the ability to print at twice the strength of cinder block without any molds, forming, setup, anything. Print in place and give customers designs they have never ever fathomed, never even could imagine. Architects like to do this stuff, but every time they do, and the subcontractors come in to start bidding this stuff, it's too expensive. And then they get back to just fall asleep, square walls, straight walls, square angles and corners. Architects want to do this kind of stuff. Now they can. So, okay, let's talk about wall design for a little bit. Your engineer, based on your code, on a bearing wall, non-bearing walls, he has to decide, is he going to print a wall that's 6 inches wide, 8 inches wide, 12 inches wide? Is he going to put internal mortar support in it? And if he is, how tight is that mortar support? Because that will drive the cost of this wall up. We know that a wall that's printed like 1 inch by 1 inch 8 feet tall. The cost per cubic inch is 0.005, a half a cent a cubic inch, at about 2,400 psi. Okay. Then you can go up from there. Okay, obviously, you could pour a hollow wall, put rebar in it, and pour it solid concrete, or you could print a wall with internal mortar support, put rebar where you want because you're isolating cells now, and just fill these other areas. There's lots of different ways and makeups of a wall. So here's a hollow wall. Okay. Ideally, you want to stay hollow, because if I can stay hollow, I can drop my electrical lines in, my plumbing lines in, and I'm not drilling hundreds of 2x4s. Okay. So this is going to make your electrical and plumbing a lot less expensive as well. Okay. So ow. Okay. It's strong, okay? Nobody has to worry about this stuff being strong. It can be as strong as you want it to be. And without rebar and mortar support. But for your first project, you're probably gonna say, you know what, let's give the building, I know a lot of these guys haven't opened a book in 20 years, so they're probably not up to speed on the new strengths and new technology with just concrete, with just cement-based mixes. So, you can see this one's, okay, if you look down on this more, it's wider than this one. Your structural engineer is the one that has to decide that. Are we going to go completely hollow? Are we going to go hollow with rebar? Are we going to go hollow with mortar support like I just showed you back there? Okay, now, when you're trying to figure out what does that cost a square foot, okay, if I have a wall, okay, like this, that's a hollow wall, okay, hollow. Okay, versus this one, okay, this one has mortar support, internal mortar support printed in the middle. And they're like, okay, well, how much is the cost if we have internal mortar support? Hell's sakes, I don't know. What did your engineer say you have to have? When you can tell, okay, because this is also a hollow wall, okay. You see the difference? If you're printing this at 1 inch, okay, if this is actually this wide, 1 inch, okay, then, which it doesn't have to be, it can be 1.5 inches. It can be 2 inches, your mortar support in the middle. And same thing with your wall. Here's a hollow wall, okay. Is it going to be 4 inches? Is it going to be 6 inches? 8? 12 inches? How wide is it going to be? Once your engineer has told you, okay, we're going to do this wall because of the calculations and the strength back from the lab, with those calculations, I've determined we can build a wall and it will surpass everybody's requirements for a bearing wall or interior walls or exterior walls. Okay? But getting back to cost again, you have to know a couple things. So, okay, one side of the wall, second side of the wall. One side of the wall, second side of the wall. That's what I'm drawing right here, okay? Because now the question is this going to be 1 inch, 3/4 inch, 1.25, 1.5, 2 inch? Have to know. Once you have that, then we can figure out what the cost is for the hollow wall, okay? When we come back in here and do this, okay, right here, okay, what is it? Same thing. Is it 1 inch, 3/4? Okay. When you're done, you can figure out how many cubic inches you have per linear foot of wall, and you'll know exactly what your cost is going to be. But I can tell you, for a wall like this, hollow wall, about 1.25 inches on both sides, your cost for this wall is about $11 a running foot. No rebar, no backfilling, just a wall like this, hollow, 1.25 inches on both sides. You're gonna be at about $11 a running foot, okay? So hopefully that clears up and explains some of the, you know, I realize it's a new technology, it's hard for people to get their head around it, but if you think about it, it's kind of not, okay? It's a matter of breaking it down into cubic inch. How many cubic inches of print do we have? How tight are we doing this? Okay, are we doing it on 12-inch centers like this? Okay, are we doing it on, those almost look the same. Oh, we went from the center. Okay, or are we doing it on 8-inch? Okay. Some people have asked about, okay, I want it to look just like a cinder block wall. Well, I wouldn't, okay, it'd be not necessary. So if I have a, let's say 6-inch, okay, then I've got to, I print the perimeters, okay, then I got to come back and come across here and down there and over here and over here inside the wall. What has that done? Well, okay, I have, not only do I have just the wall cost to print the perimeters, now I'm duplicating it right here, so that adds, plus I have my horizontals. I got my verticals that are running parallel with my wall. Now I have my horizontals. You got to add those all up. But I mean, why would you try and print a wall that looks like a cinder block when you can do this? I can make these as tight as I want. Okay. Again, double the strength of a cinder block wall in the first place. But if you know what, if you're square hole, square peg, and this is just the way I want to do it, knock yourself out. But that costs a lot more, okay, than this does. And that's why when you look around the world, this is what people are doing. So, but if this is what you're going to do, same thing. Figure out how many linear feet you have, break it down into cubic inches once you know how wide you're printing, and voila, you're there. So, this is the stuff we talk about every day. Actually, I mean, if you look around right now, we have a university from Arizona here for their training, and this is one of our classrooms that we work in, and we talk all the time, okay, talking about pass height, because the next big question is, well, what's the labor going to be? Okay, well, it depends. Are we printing every single pass at an 1/8 inch? Okay, are we printing our passes at 1 inch? What mix are we using? Stronger mixes, I can print faster. I use weak mixes and print too fast, what happens? Okay, the base, the thing falls over. We have lots of experience with stuff falling over. Okay, 2.5, 3 years of watching cement fall over, fall over, fall over. You want to get some other ideas, okay? Here's a wall we had one of our classes print. Look at this wall, it's disgusting. It looks a lot like a lot of the other walls you're seeing out there right now. Okay? What happened here? What happened here? Okay? This, what happened? So, different mixes, different print speeds, different pump speeds give you different effects. We don't want your crap looking like this. You know, most everybody out there, they won't show you printing a wall from there up to here in one pass. Okay? They print this high. They let it dry. Heaven forbid they try and go this high, it might fall over. Okay? Then they print this high again. Well, that's super safe, it's just super unnecessary. We print from there, we print to there, and it is all done in one pass. And then while this is cured down here at the bottom, we actually get on it and start finishing it, so that when we're up here, okay, when we're done, it looks like this. Smooth wall. The opposite side, it looks like stucco. So, The type of mix that you use will determine the speed at which you can print. How much you print in each pass, okay? If I'm going an 1/8 inch, 1/4 inch versus an inch, I mean, there's 4 times just to get, if I print an inch, 4 times faster than if I print a 1/4 inch, right? Yep, exactly. So, anyway, hopefully that answers some questions for you. We'll just keep trying to put more videos online that will address what seems obvious to us. We've been doing this a long time now, but it isn't so obvious. And so that's why this video's here and while we're making it right now. Because Sonia says she's getting tired of answering the same question over and over. In any case, try and watch all of our videos. We know it's easy. This isn't Maytag, okay? This isn't Dell Computer. We don't make tens of thousands. Please don't call me and say, well, what's the life expectancy of the printer? For hell's sakes, call around. First of all, you can't get a hold of anybody. Second of all, do you really think that there are that many printers that have been printing for 4 years that anybody could really say that? Now, we can give you our best guess. If you're square hole, square peg, let me just stop you right there and tell you, hang up the phone, call back in 3 years, we'll give you everything you want. We've been doing this for 3 years, but this isn't a square hole, square peg thing. And so there's certain personalities, that's who they are, and that's the way they are. You know, in the nicest way, call somebody else. What you're going to become a part of is a family of entrepreneurial, like-minded people that realize they're part of the solution. They're not going to be part of the problem. They're all working together. They're trying to help each other. The excitement level is palpable with our customers. So anyway, we welcome you down here. There is quite a list of things that you have to do to get here before we can meet with you. But we welcome you here. We do welcome your calls. The only time we get a little bit frustrated is if you are calling and asking about stuff that we have already answered. If you go online, you'll see I've offered more information, more videos that get into the specifics than all the rest put together. Plus, you can actually speak to us. So, watch our videos, please, we beg you. So that when we're finally on the phone with you, we're talking about stuff that matters. We're talking about details that we're unwilling to share until we have non-competes and NDAs in place. So that helps us a tremendous amount. Watch our videos. Please read and pay attention to the stuff that we send you once you register. Outside of that, it's fun as heck. We love the people that we are meeting with. The people that understand construction, they understand engineering, or have somebody on their team that does. They understand real estate, they understand submittals, building departments, architects, engineers. A lot of people, oh, this is going to be great. I'm going to get a contractor's license and I'm going to start a company. I want to buy one of your printers. I'm like, oh, brother, okay, it's a pipe dream. Okay, I can't instill into you the years and years of experience that these master craftsmen and contractors and general contractors have. I can't teach that. There's universities, 4 years for construction management degree. So I can't teach that in a 3-week training course. By the way, our training course is 3 weeks. You have to send a print crew of 3 people and they'll be here 3 weeks printing and printing and printing. But yeah, to those who do have that experience, or at least have that team, when they come here, they always buy. The other guys, they're afraid of their own shadow. Well, what if the building department says no? And the building department says no. Structural engineer is the only one licensed in the state to sign off on plans and to say they meet code. Once he does his job, okay, they can't say no. They can say, I don't understand it. Can you explain the math or whatever else? But please understand, it is the structural engineer that went to school for years and years, okay, that is the single authority for drawing a set of plans. Take them to the building department, depending on what mix you're using and what method you're trying to do. They're going to have some questions for you. Part of the training you get here, but we don't teach structural engineering. We don't do your house plans for you. We sell the printer. And when all that other stuff is done, our printer will print what has been designed. It's kind of like Epson. Okay, they sell the printer. They don't give you the graphic artist that will create pretty pictures to come out of it. So we are excited to see you. Hope that answers some questions. I know I'm talking way too much on this one. Feel sorry for you guys. Get some Adderall and some Ambien. You'll probably need both of those in the course of the next few months as you're trying to just absorb all the exciting opportunities, and you know that this is opening up. This is changing a lot of stuff. So that being said, thank you guys. We look forward to seeing you soon.